Hello everyone. Today we are going to explore a very important but often invisible part of program execution, something called a linker. When one writes a C or C++ program and compiles it, we get a magical message, compilation successful. This may not be the exact message, but kind of message that we receive. At that moment, we feel the program is ready to run. But the truth is, it's not ready yet. What you have at that point is not the final working program, but several machine code fragments, one from each source file. They need to be connected. Just like multiple roads in Pune city needs to connect different areas like Kothurud, Aund, Hinjawadi for traffic to flow smoothly. And that process of connecting is what the linker does. The linker's job is to make sure that every part of your code, every function, every variable knows where to find the others. It is the final step that makes your compiled code an executable. Think of it like this. If the compiler is like a language translator who converts each paragraph separately, the linker is the editor who arranges these paragraphs into the right sequences, fixes references, and publishes the final book. Let's now understand the technical meaning behind this. The linker is a software tool that operates after compilation. It takes multiple object files, which are compiled outputs of your source files, and intelligently combines them into one executable program. Here is what actually happens. Each .c file you write, for example, main.c, calc.c, and display.c, is compiled separately. So you get three object files, main.o, calc.o, and display.o. Each one has its own machine code, but they are still incomplete. Why? Because they may depend on functions or data defined in other files. The linker steps in here and connects these dots. It ensures that every call to a function like sum in main.o knows exactly where the sum definition exists, maybe in calc.o. Imagine Pune's public transport system. Each PML bus route serves a specific area. But to make city-wide travel possible, routes must interconnect at major junctions like Swargate, Shivaji Nagar, and so on. The linker plays that same role. It connects every route in your program so that the data and control flow can travel end to end. Without the linker, the program is like disconnected bus routes with no interchange points, and that results to no complete journey. And you definitely cannot complete the journey in such a case. In modern programming, we follow the principle of modular development, breaking the large program into smaller manageable units or modules. Why this is so? Because it helps us to organize the code, work in teams, test parts separately, and reuse modules later. For example, imagine developing a large department or college management system in Pune. You would create one module for student information, one for attendance, one for examination, one for result processing. Each of these modules is written and compiled separately, resulting multiple object files like say student.o, exam.o, result.o, and so on. Now the issue is these modules don't work independently. The result module may call a function from the exam module. The student module may reference to attendance data. And during compilation, these links are not resolved yet. The compiler just leaves the placeholders. The linker is what performs the final integration, connecting every function call to its actual definition and every variable references or reference to its memory address. So if modular compilation is like constructing separate building in different parts of Pune, then linking is like building the roads, bridges, and power connections that allow those buildings to form one functioning city. Let's carefully walk through the entire linking process. Step 1 is source code. This is the set of source files you write. For example, main.c, mat.c, display.c. Each one contains logic for a specific part of the program. Step 2 is compilation. The compiler takes each source file and translates it into an object file, machine level code stored in .o or .obj files. At this stage, cross-module references still exist. The compiler simply marks them symbolically, saying that this function or variable will be resolved later. Now, while seeing the nm output, nm command output on Ubuntu, we saw that if a printf is there, it had u undefined. Even in readelf, we see und written there. Now, step 3, linking. The linker now takes over. It gathers all object files together, resolves the symbolic references, and connects everything. This also includes required libraries. For example, the C standard library for functions like printf or the math library for functions like power or sqrt, square root. The linker ensures that every instruction in your code knows exactly where to find the functions and the data it depends on. And step 4 is executable. After linking is complete, we get the final executable program. It could be a.out or elf or an exe file. It is ready to be loaded into memory and executed by the operating system. Without linking, your program is like a metro line with incomplete tracks. The trains, that is, instructions exist, but they can never reach the destination. Like the example that I gave here is, think of the entire process like developing the Pune metro. Each station is constructed separately. That's like compilation. But until the tracks, power lines, control systems are connected, that's linking. The metro cannot run. Once the linking is done, the entire network operates as one continuous system. Now, further, let's break down the 4 major functions of a linker. First is symbol resolution. When we write a function call, like for example, calculate total, the compiler doesn't know where it exactly or actually exists. It just marks it as a symbol. The linker searches all object files and libraries, finds where the calculate total function is defined, and updates all references to the point with the correct memory address. It's like setting up direction boards across Pune. Each one points correctly to the target location. Second step is relocation, or second concept is or function is relocation. Each object file assumes its code starts at address 0. We saw that while we seen the object code through objdump. When multiple files are combined, these addresses overlap. Like every file, if it is having 0, then problem starts. The linker relocates them so that every function, every variable, and the data section has its own distinct location in memory. And it's similar to assigning plot numbers in developing area. Every building must have its unique space in the final city plan. Third concept is or function is library handling. Many functions we use, for example, printf, scanf, or say math function, they are not written in our code. They are fetched from the libraries. The linker includes only the specific parts of those libraries that your program actually uses. And this keeps the executable compact, similar to how a restaurant in Pune stocks only the ingredients it needs for the menu, not every possible item from the market. And lastly, the final concept is combining the object files. The linker merges all object files together along with the library components into one single seamless program. This integration is like connecting multiple power substations in a grid. Once linked, entire system runs as a continuous network. So to conclude our discussion, without linking, even the most perfectly compiled code cannot run. Our program remains a collection of disconnected object files filled with unresolved references. The linker is the one that transforms these separate parts into one coherent working system. It resolves symbols, it adjusts memory locations through relocation, incorporates all required libraries, and generates the final executable file. In other words, the linker is like the final phase of city integration, connecting roads, wiring power lines, and activating systems so that the entire city functions together. So next time when your program runs successfully, remember it's not only the compiler that made it possible, but also the silent architect behind the scenes called as linker.